We'll do a slightly different convergence and divergence question. So we're going to ask if the sum from n equals 2 to infinity of the square root of n times 3 to the n converges or diverges. So let's once again use the DCT. The intuition that you kind of want to form here is is that this looks, if I didn't have this square root of n here, this would look very much like a geometric series. So the thing to observe is that 1 over the square root of n times 3 to the n is going to be less than 1 over 3 to the n. Why? Because all I'm doing is since I'm starting with 2, I'm actually making the denominator bigger because I'm going to multiply it first by the square root of 2, then by the square root of 3, then by the square root of 4. So this term is going to have a larger denominator, and therefore the fraction is going to be less. So, and of course this is just equal to 1/3 to the n. So what I'm going to do is I'm going to let an equal 1 over root n times 3 to the n, and bn equal 1 over 3 to the n. In that case, I can easily see that, first of all, both of these terms are positive for all n greater than 2. There's nothing negative in either of these definitions. So what I can see is that 0 is less than or equal to 1 over the square root of n times 3 to the n, which, as I demonstrated up there, is less than or equal to 1 over 3 to the n, which is equal to 1/3 to the n. Why am I writing it in this form? Because this is now the general term of a geometric series that we know converges. So what we can say now is that the sum from n equals 2 to infinity of 1/3 to the n converges. We're going to state a slightly different rationale. I know that we've always done this using p-series, but the rationale that I'm going to use is that this is a geometric series with r equals 1/3, so that means that the absolute value of r is less than 1. So that's the proof that this converges. You always have to if you're comparing, and these are in fact comparison tests, if you're comparing the given series to some other series, you have to be able to make the argument that that other series in fact converges. And in this case, the reason it converges is because it's a geometric series with r equals to 1/3. So therefore, since we have the inequality right here, and we have a proof that the series we're comparing to, it converges, we can conclude therefore that the sum from n equals 2 to infinity of 1 over the square root of n times 3 to the n also converges. That's our conclusion, and this is in fact a proof of our conclusion, so we end it with the box. So just note here what you have to have. In order to form this proof, you first of all have to have the name of a test that you're applying. You then have to have a correct inequality, and then 3, you have to have a claim that you can back up why the series that you're comparing the given series to converges. That's usually going to be either because it's a p-series with known properties of convergence, or because it's a geometric series. And that's one of the nice things about having p-series and geometric series that have very nice rules about convergence and divergence, is that you can make a very quick conclusion about whether that series converges or diverges.